As the CIMAC Congress returns to Helsinki after 35 years, it is a very different large engine industry that delegates experience, but a very familiar price for a barrel of oil. In 1981, engine building and engine applications are still local, not global. There are more than 30 large engine builders. Liquefied natural gas carriers have steam turbines, and coal, nuclear and hydro still dominate power generation. Despite fierce competition from the Far East, shipbuilding still takes place in Europe. But how many delegates at Helsinki 1981 could imagine the dramatic changes of the next decades? In 1981, engine and component developers were still adapting to HFO. The development focus was fuel economy, but papers at the 1980s congresses herald the themes of the 2000s. While interest in gas engines starts to grow both on land and sea, and two giants are awakening. The first engines with electronic control emerge, and China becomes everybody's favorite market for generator sets. Industry concentration and globalization begin, and first emissions legislation for heavy-duty engines arrives. In the 1990s, the large engine industry stands before its greatest challenges and answers with the greatest acquisition of knowledge in its history. Emissions are in the regulator's sights. What starts with cars and trucks soon extends off-highway and to boats and ships. The writing is on the wall, and CIMAC founds working groups for noise, automation and monitoring, exhaust emissions control and users. Engine development requires critical mass, and serving shipbuilders in another hemisphere requires worldwide presence. Industry concentration results in a handful of global manufacturers. Electronic controls are now robust enough for large engines, while computer development tools revolutionize engine development. The electronic revolution reaches marine and industrial engines. At the end of the decade, a two-stroke diesel achieves specific fuel consumption below 160 grams per kilowatt hour. What started in the 1990s continues and accelerates, especially emissions reduction. The new millennium sees the focus of engines R&D change forever. While world trade booms, the biggest problem is delivering engines as demand peaks. While engine power breaks the 100,000 horsepower barrier as each new container ship sets a new record. To unlock the emissions, efficiency and power potential of large marine engines, the EU sponsors the Hercules Joint Industry Project. Almost forgotten names return as emissions legislation tightens. Fuel consumption penalties are no longer acceptable as greenhouse gas awareness grows. China continues to grow, first as a market and then as a producer of vehicles, ships and engines. Overnight, boom turns to bust. But as the 2000s progress, technologies emerge that can only be realized with electronics. And they promise vast improvements in emissions, fuel consumption and power density. Over 100 years after its launch, the diesel engine still offers the best combination of efficiency, torque and load acceptance. And gas engines are making great advances. As we see with Miller, engine technology can still make quantum leaps. The decade opens with IMO Tier 2 and Tier 3 at its midpoint. Gas starts to challenge oil's domination, adding financial incentives to emissions benefits. Finland plays a major role in this dash for gas. IMO adds the Energy Efficient Design Index and Ship Energy Efficiency Management Plan to Tier 3. CIMAC responds with working group system integration. IMO Tier 3 is delayed, with some nations objecting to the timescale. A compromise is reached, but engine builders and their suppliers are shaken. Gas engines, EGR, SCR and scrubbers emerge as the diesel emissions technologies of choice, although after-treatment needs consumables and more space. The final decade on our journey starts with gas engines setting efficiency records. At its midpoint, 4-stroke diesels with modular design, common rail, 2-stage turbocharging and Miller cycle set record efficiencies, power density and huge NOx reduction. These quantum leaps are only the start. The years since Helsinki 1981 have produced a lean industry making efficient engines that are clean, powerful, long-lived and can run on many fuels. Above all, thanks to CIMAC, the large engine industry is more than ever a forward-thinking partner of progress and has a leading role in an holistic approach to greenhouse gas and noxious emissions. The renewable revolution can rely on fast-reacting clean engines as backup for electricity that depends on the weather. On land and sea, hybrid technology promises huge gains through downsizing and energy storage. CIMAC's new working group, System Integration, looks set to be its most vital. Digitalization will continue. What started with fuel injection now encompasses whole power systems. Autonomous vehicles and vessels are reality. Developers use an array of CAD tools. Sophisticated parts can be 3D printed. Remote monitoring gives insights to improve maintenance and enable engines to cope with every real-life situation. The CIMAC working group, Electronics and Software Systems, becomes Control and Automation. As CIMAC meets again in Helsinki, the large engine industry is more than ever a vital foundation stone of sustainable power for a developing world.